All right, so today we are going to work on things you need to know before we start Monday on trig. Some of this stuff was covered in Algebra 2, some of it was covered in Geometry, so we'll just walk through it real quick. The geometry component is mainly the special right triangles, and we'll talk about this when we get into the unit circle if you discussed it in Algebra 2. All right. The one on the left is the 30, 60, 90 triangle. All right. The smallest leg is x, the middle leg is x root 3, the hypotenuse is 2x. The main thing to remember is the hypotenuse is double the short leg. The long leg is the short leg times root 3. If you remember that the hypotenuse is always double the short leg, you can always get the longer leg using the Pythagorean theorem. The isosceles right triangles, this is the one on the right, either with the congruent sides in the right angle, the 45, 45, 90 triangle. All right, the two legs are the same length, making an isosceles, x and x. And then the hypotenuse is x root 2. Again, if you use Pythagorean theorem, you would get the same thing, but it makes your life easier. All right, so on the left is a 30, 60, 90. On the right is a 45, 45, 90 right isosceles right triangle. All right, so if we look at the 30, 60, 90 on the bottom, the hypotenuse is 10. That means the shorter leg opposite the 30-degree angle is going to be half that. We all know, one up top, sorry, my bad. Since the one leg is 12 and the isosceles right, okay, that means the other leg is also, the hypotenuse is 12 root 2. And the other leg is also 12. Those two sides will always be the same. The hypotenuse will always be that leg times root 2. For the 30, 60, 90 on the bottom, they're giving us the hypotenuse, which is 10. After that's going to be on the 30. So the smaller leg is going to be 5. And then the longer leg is 5 root 3. Okay. If they give you the sides with the radical in it, for example, the 30, 60, 90, they give you the long leg is 4 root 3. The shorter leg down here is going to be 4, you just drop it, and then the hypotenuse, which is double the short leg, is going to be 8. And the isosceles right on the bottom, the hypotenuse is 9 root 2, so to get the leg length, we're going to get 9. So both legs are going to be 9 in that case. All right, so the harder examples is when they give you a side that normally has a radical without a radical. In the one on the 30, 60, 90 on the top, they give you the longer leg is 12. The short leg would be 12 divided by root 3. Well, as you know, we can't have a radical in the denominator, so we have to rationalize. So we multiply top and bottom by root 3, giving us 12 root 3 over root 9, making root 9 is, of course, 3. 3 goes into 12 4 times, 4 root 3. So the short leg is going to be 4 root 3. All right, if you want to do it without it, just realize you divide that by 3 and then put root 3 alongside it. Once we have the long leg is 4 root 3, hypotenuse is double that, so hypotenuse is going to be 8 root 3. For the one on the bottom, the only difference is instead of dealing with root 3, we're dealing with root 2. So we would divide by root 2. The long way, we would end up with 20 root 2 over 2. 2 goes into 20 10 times, giving us 10 root 2. So both legs in that case would be 10 root 2. Here we divided by 3. Here we would divide by 2. So the fastest way of doing it, divide the hypotenuse by 2, and then make that. Okay? Don't forget, if you start with a square, you draw in a diagonal. Those are the same, the legs, and that is a right angle. You have yourself an isosceles. You have two actually isosceles right triangles. Now, in this review, there's also radicals. All right. So one of those radicals is one of those problems is 3 root 20 times root 5. The advantage to multiplying is we can multiply anything we want. Now, one way of handling it is simplifying any radicals first. So if I look at root 20, 4 goes into that. Square root of 4 is 2, so that's coming outside. So I have 2 root 5. So it would be 3 times 2 root 5 times root 5. All right, 3 times 2, the outside numbers are 6. Root 5 times root 5 is root 25. In case you don't recognize, they cancel out. because root 25 brings us back to 5. 6 times 5 would give us 30. If you want, you can multiply the radicals right away. 20 times 5 is 100, so that would be 3 times the square root of 100. Square root of 100 is 10. 3 times 10 is 30. Again, depends upon you and what you want to do. Okay, when variables appear, square root of 81, p to the 6, p to the 9, p to the 12. Your coefficient is a perfect square, so that's going to become 9. The even ones you just cut right in half. Half of 6 is 3. So we end up with p to the third. Half of 12 is 6. So we end up with t to the sixth. Q is the remaining odd one. When you have an odd one, don't forget, 9 minus 1 is 8. Half of 8 is 4. So q to the fourth is outside, and anything with an odd is going to have radical q on the bottom. All right. So the simplified version would be 9p cubed, q to the fourth, t to the sixth. And eventually, hopefully you went through in Algebra 2, the p to the third would have absolute value. Whenever you start with an even and end up with an odd, please put absolute values around the odd exponents. All right, adding and subtracting, we need like radicals. All right, pick either one. We got 5 root 72 minus 4 root 200. All right, 100 is a perfect square and goes into 200. The square root of 100 is 10. So 10 would come outside and multiply by 40. That would give us 40. 2 would remain inside because 200 divided by 100 is 2. I would suggest right away you then divide that by that remaining radical there. See if you have a perfect square. You do. 72 divided by 2 is 36. Square root of 36 is 6. So 6 is coming out. So 5 times 6 is 30. So now we got 30 root 2. Okay, there's the long way of showing it. All right. Simplifies down to 30 root 2 minus 40 root 2. Now they're like radicals, so we can subtract. 30 minus 40 is 10 with a negative in front. So my final simplified answer would be negative 10 root 2. All right, so the key with that one is once you simplify one, divide the other, because chances are you need to be able to simplify. All right, maybe a refresher on rationalizing the denominator. All right, when it's simply a radical, like in the special right triangles, all right, we're going to have, okay, you just have to multiply top and bottom by the radical. When it's a more complex expression, when it has a rational and radical in it, you multiply by the conjugate. Remember, the conjugate is simply the same numbers with the opposite sign. So since the original denominator has minus, we would multiply by 2 plus root 3, top and bottom. To simplify, we would either distribute or FOIL. 5 times 2 gives me 10. 5 times root 3 gives me 5 root 3. 2 times root 3 gives me 2 root 3. Root 3 times root 3 gives me 9, which square root of 9, which simplifies down to 3. When I do the bottom, 2 times 2 is 4. 2 times positive root 3 is 2 root 3. 2 times negative root 3 is negative 2 root 3. Root 3 times root 3 is the 9, so minus the 9. Okay? Now when I collect like terms, 10 plus 3 is 13. 5 root 3 plus 2 root 3 is 7 root 3. If you do the process correctly, these two should always cancel out. Root 9 is 3, so that simplifies down to 4 minus 3. 4 minus 3 is 1. My denominator is 1, so I don't need to write it anymore. If you want to, you can. I end up with 13 plus 7 root 3 for my final answer. All right, polynomials will always be there for you, no matter what. All right? So, if I'm going to factor x squared minus 7x minus 30 equals 0. All right, x squared minus 7x minus 30 equals 0. All right? A is 1, so I'm just looking for two numbers that go into 30 that subtract to 7, 10 and 3. If your perspective is add up to negative 7, then you have the negative 10 plus 3. Otherwise, it's whatever that sign is the larger of the two numbers, however you did it. So I end up with x minus 10 times x plus 3 equals 0. The zero property tells us one of those expressions would have to be 0, so I do the opposite of the constant. The opposite of negative 10 would be 10. The opposite of positive 3 would be negative 3, so those are my two solutions. Special cases, now two things. Number one, these are special cases. Number two, they're not equal to 0, so all you're doing is factoring. The one on the left, is a difference of two squares, x squared minus 49. That factors into the square roots, one positive, one negative. So I got x plus 7, x minus 7. The one on the right is 4 terms, so I look to group. When I group, I factor the GCF out of both halves. The GCF of the first half is 2x cubed. The third term is negative, which means my GCF of the second term would be negative. Okay? Now, to save yourself a step, look to see if they have anything first, and they all have an x. So I would factor out the x first. Makes your life easier. Okay, but you could do it the other way, it's fine. 2x cubed plus 18x squared. 2 goes into 18, they both have an x squared. So I have 2x squared times x plus 9. All right, again, like I said before, the third term is negative, so I'm going to pull out a -1. That also gives me x plus 9. When I group successfully, those are the same, so I end up with x plus 1. The other binomial is the combination of the GCFs, 2x squared minus 1. Don't forget about your x on the outside. Okay? 6x squared minus 3x minus 30. Again, when a is not 1, the first thing I look for is a GCF. 3, which is the b, the coefficient of the x, goes into both 6 and 30, so I pull it out. It makes my life easier. 2x squared minus x minus 10. All right, now you're going to factor, depending upon trial and error, grouping, slide and divide. In class, I'll go either today, Thursday, or Friday. I'll go through either one. Either way, it factors into 2x minus 5 times x plus 2. So there's your simplified answer. Please, when you pull out a GCF, don't forget about pulling it out. All right, last thing is zeros of polynomials. All right, remember, 0 is where it crosses the x-axis. It's where the value of y is 0. So the first thing is, how many zeros are in the graph polynomial above? 1, 2, 3, 4. Remember, if it switches direction, which means it has a multiplicity that's even, that's when you have the bounce. We talked about in Algebra 2 last year. That's still a 0. So if it came to here and then immediately went back down, that would still be a 0. So I got 1, 2, 3, 4. So there are 4 zeros in that problem. Okay? Again, remember, if it bounces, it's still a 0. Second point, what are those zeros? Well, remember, those are the opposite of the values. Those are the roots of the values. So that would be -4, crosses at 0, 1, and 6. So those are my 4 zeros, -4, 0, 1, and 6. Now, last thing would be bonus question. What is the original polynomial? Remember, those zeros come from the opposite of the roots. So, for example, the opposite of -4 is +4. Yep, 0 doesn't have an opposite, so we just write that of x. The opposite of 1 is a -1. The opposite of 6 would be -6. So those would be the factored polynomials that give us that. Now you can multiply if you want. You can multiply those two together, which would give you x squared plus 4x. All right. Go back. Multiply these two together, you'd end up with x squared minus 7x plus 6. Now you would just distribute this through to give you your final answer, which is x to the 4th minus 7x cubed plus 10x squared minus 28x plus 24. And please don't forget that exponent, which is 4, should be equivalent to the number of zeros. All right, again, we're going to go through the same thing. For those of you in the B sections, we're going to go through the same thing tomorrow in class. We'll go through all these step by step. So if you have a question about factoring or anything, let me know. All right, the assignment itself is in Edge Elastic. All right, it is due Monday morning at 7 a.m. Be good.